Today we have Associate Clinical Professor Nick Kay from the University of Chicago speaking on how generative AI impacts jobs. Nick, the mic is yours.
Thank you so much, Jose. It's great to see everyone today. I see some familiar faces, some former students, current students, future students, hopefully. Today the topic is the Gen AI and how it's going to change the jobs of the future. Of course, as a full disclaimer, no one knows for sure, but at least we have some hypotheses that are supported by some of the recent findings and facts. And then what we'll do, I'll cover the slides. I'll give you my next point of view. And we will leave some time at the end towards Q&A. If you have a question in the meantime, feel free to post them in the chat. And I will ask Jose to please keep track of your questions. If we are unable to answer some of them, I promise we will get to those after the presentation. All right, so now the big topic is what and why and how AI changes the workforces, the requirements in the marketplace, how does it really change the job? What I'd like to do, I'd like to start with a statement that was just about 2 weeks ago at the beginning of January. Mark Zuckerberg made a big statement during his podcast with Joe Rogan, and he said that AI will soon replace most of the mid-level software engineer at Facebook, Instagram, and WhatsApp. That's quite a big statement for a company that employs tens of thousands of software engineers. So now, how do we know whether it's true and what's going to happen? So what I would like to do, I would like to take everyone back in history and see if we can learn from historical breakthroughs on how the technologies do change the market. What I'd like to do is I would like to first take you to 19th and 18th century so we can look at the steam engine revolution. Then we'll take a look at the economic growth it created, and then we will take a look at kind of two more recent events. So steam engine, big big industrial revolution. It actually spurred industrial revolution itself. Productivity and industrial output greatly increased, and a lot of economies expanded as well. However, it actually forced a lot of the displacement as well. Agrarian-based businesses could no longer survive, and it kind of shifted a lot of the workforce from farmers to urbanization, and it displaced a lot of the traditional craftsmen. So instead of having your blacksmith right by the farm, instead the equipment was made at the factory, in centralized factory in urban setting, and people had to move. Lots of families were disrupted, and it created a brand new workflow. So now let's take a look at another one. Also in 19th century, the Luddite movement, which originated in early 19th century in UK. And it was a protest against all of the industrial machinery. So they saw the machinery as a threat to the traditional craftsman job, and they tried to break the machines, physically break the machines. As we know, in 2025, looking back at the history, it didn't really work out. The machines did prevail. And most of the manual jobs in textiles, particularly, were replaced by the machines indeed. However, it was not all doom and gloom, because the move really underscored how the technology can be balanced with employee welfare. Their working hours were greatly reduced. The safety of the workers were promoted. And while in reality, the textile industry required a lot fewer physical laborers, the ones that ended up in that industry fared much better. So now that all seems like a distant history to you. So now why don't we take a look at the more recent one? The computers were invented not so long ago, and they really displaced a lot of traditional businesses. So a lot of the manual tasks like manufacturing and baking became automated, especially low-skilled and repetitive work become automated. So when was the last time someone saw a travel agent that you can walk in and kind of read the magazine and try to book your travel? Those things don't exist anymore. So now, did it displace a lot of work? Yes, for sure it did, but it also created a lot of the new jobs. IT support, software development, data science, AI, all the things we love, they are all new and would be absolutely impossible without today's computers. So now if I break it into the 4 different pillars, so the pillar number 1 is automation. Of course, technology, AI leads to a lot more efficient work processes. Those processes, whether we like, do reduce the need for human labor. And so things like data entry, clerical jobs, they do disappear. Second is, what about new jobs? It does create a lot of new jobs. So the jobs that I personally love the most, like AI engineering, data engineering, ML engineering, all of them are brand new, would be absolutely impossible without the technology, and these jobs did not exist before the computers were invented. So what does it leave us? It does move the skill set. So the different set of skills are required. So we need digital literacy. We need to know how to do data analysis, software development, ML ops, and those in a society that can adapt and learn new skills, they tend to fare much better than those who can't. And finally, it also leads to a phenomena of remote work and globalization. Sometimes you don't really care. You can be working with in a globally distributed team, and your counterpart can be 10,000 kilometers away. And what it means that people have a lot of flexibility, at least until recently the company started implementing the return to office. But for most of us, it creates a lot of flexibility. It also creates a lot more competition for the job. So, for example, if you're applying for a job as a machine learning engineer or software developer, especially for the basic tasks, let's say you're building a UI in React, you probably are, if you're based in the United States, you are competing with the developers in China, in India, in Mexico, and everywhere else on the globe, because those skills are very easily portable. So now, let's take a slightly different angle. We looked at the history, we kind of see what are the major shifts. What I would like to do, I would like to take you through some of the applications of Gen AI, and then we can see what are the technologies that are enabling them. So now, what is the future of AI? Of course, the most logical thing to do would be to ask AI, can we find out what AI is bringing us? Well, maybe it's going to give us a good answer. In most cases, it probably will. But let's take a look at the ones that at least are very close and dear to my heart. So I started this presentation with opening from Mark's comments. Now, if I go back exactly, 2 years and 3 days ago, that is honestly my favorite tweet of all the times. Or shall I say post on X, I guess, nowadays, of all the time. So Andrei Karpathy, former CTO for Tesla, posted that the hottest new programming language is English. So why is that so important? Because if I roll back the clock just a couple of years ago, the way you would start new development, whether it's an AI or in a data science or in traditional software development, you probably would go into your favorite search engine, you will find some code snippet, and then you would kind of start in building on top of this code snippet. Very few people start from scratch. Right now, we really don't need to go and search for the code snippets on a Stack Overflow, because you're explaining in a plain English to your favorite copilot, whether it's a GitHub copilot, it can be anything, it can be GPT, it can be Anthropic Claude, can be Google Gemini, can be DeepSeek model, whatever your preference is. You're explaining the problem and you get some results back. Those results back are not perfect. They need some tweaking, they need some knowledge, but it certainly is much better than nothing at all. Staring at the empty VS Code is daunting nowadays, right? So AI gives you the framework. There are errors you have to fix. Sometimes you work with AI to fix them, sometimes you fix them yourself. But it doesn't matter. The thing is, you do not start from ground zero. In the way you describe the task, you describe it in a plain language. If English is not your language, you can describe it in Spanish or Mandarin. It doesn't matter. You still get the code. So the big next one, in my perspective, is the enterprise assistant. So what does it do? Enterprise assistant is a lot of companies have, especially if you work with the big corporations, the consulting organization, have a tremendous amount of internal knowledge. Thousands and thousands of pages of internal information, documentation, everything is documented somewhere, but good luck finding any of this. And so we see a lot of those enterprise assistant applications that are able to navigate incredible wealth of internal data and give you a targeted, well-curated response to those. One of the first applications I really liked was McKinsey Lilly. And just literally after 2 weeks of being launched, Lilly fielded 50,000 questions. Think about big consulting organization like McKinsey, tens of thousands of different customers and engagement. How do you ever find it out? Well, it's really hard. You can either ask your friend via email or Teams or your favorite instant messaging platform, or you can try to create an agent that contains most of it. And this is a very typical application of RAG, of retrieval augmented generation. And today's techniques like more robust agents or chain of thought RAG or tree of thought RAG are fairly stable and provide very little hallucination. So these applications are indeed great time savers. So now I am in a legal tech space, so legal assistance is particularly close to my heart. Lawyers are very well compensated. Normal human beings like myself have hard times understanding legal language. And so anything that automates it, whether it's a legal research, whether it's a document drafting, whether it's a contract redlining, whether it's a case analysis, whether it's understanding and predicting the outcomes, those functionalities are immense time savers. And they do indeed change the work of traditional either legal assistants or paralegals by automating 80% plus of what they tended to do manually, including the legal library research. And maybe the one that might not be as obvious, but it's still very important, is any type of a digital twins. So why digital twins are critical? If you think about building a big factory, and this actually case study comes from NVIDIA working with the BMW and a new factory floor. If you build a factory floor, you need to plan every single robotic arm and how they assemble different components, how the conveyor line is moving through the factory floor. If you make a mistake, even if you're off by like 1 millimeter and the arm cannot reach enough, you need to replan it all. It is a very expensive and it's a very lengthy procedure. So everything that allows you to do this in a digital twin, so you can do it in code and you can prototype it all before you actually pour a single line of concrete, is an immense help in making sure that those are completely bulletproof, that you kind of factored in all of the interconnectivity and how different robots and humans are interacting on a factory floor. So now we're going to move into a bit more of a Gen AI outlook. And we will take a look at the projections, and then I will try to do my best to answer some of the questions. So what are the job projections? I really was fascinated with the World Economic Forum, which just took place in Davos, Switzerland, at the beginning of January. And the term that seemed to be the new buzzword that seemed to be floating most often in Davos was the FOBO. So instead of FOMO, it's now a FOBO. And a FOBO is fear of becoming obsolete and being replaced by the technology and AI. So how do we make sure that we are staying relevant and not being fossilized by the tech? So before we will become all nervous and upset about what the job market will bring us, let's take a look a little deeper into this World Economic Forum and their January Future of Job reports. They tend to predict them for about 5 years out. So we will take a look at what they're predicting by 2030. So what they say is 170 million jobs created and 92 million jobs displaced. So it's still a net growth of 78 million jobs, but a lot of jobs are being displaced and replaced mostly by technology. They also talk a lot about the skill transformation. So employers value the technical skills and human-centric skill. And the interesting is analytical thinking is the most important skill that was highlighted in their report. They also stated that 39% of the current skills will require some sort of update and transformation over the course of next 5 years. Now, the scariest statement, I think, for all of us is the automation impact. 41% of companies in the World Economic Forum responders indicated they plan to reduce the workforce. They felt that AI and automation, the streamlining of operations that will bring, will reduce the workforce. So they actually want to scale down. So now let's take a look at where they see the jobs growing versus the jobs shrinking. So the good news for all of us is the things that I've highlighted in red, the things that we tend to do, or the things that we tend to prepare our students for in our program, are all the fastest growing jobs. So the single biggest fastest growing job is the big data specialist, which to me is, and I'm very biased because I teach the big data and cloud computing course at the University of Chicago. So to me, yes, great, guys, looks like I won't be fossilized in the next 5 years, and I can give you some of the marketable skills as well, right? So great to see. And then the other jobs that tend to grow faster are fintech engineers, AI and machine learning specialists, autonomous driving specialists, data analysts, and data scientists. So we can see that anything we do or anything we teach in this program are on a huge net growth percent. And let me just highlight it one more time. The big data specialist projected net growth is 115%. So huge demand for those. Machine learning specialists, 82% predicted growth, huge projections. So now we also know that there is going to be a decline in some jobs. So let's see which ones are going to be most frequently asked. And as you can see, these are mostly manual clerks, postal office clerks, bank tellers, data entry, cashiers, ticketers, accounting and bookkeeping, and payroll clerks. So what happens is, even though at the beginning of the presentation we started with a very, what seems like an courageous statement from Mark about him trying to drive down the number of engineers at Meta and replacing the work of the mid-career software engineers and developers with AI, we can see that those jobs are still going to rapidly grow and replace the manual positions of our postal service clerks and bank tellers. So how in the world does it how do we make sense of Facebook trying to reduce the number of engineers, but those jobs are certainly growing? I'll give you guys my hypothesis, which is very straightforward. If you look at FANG, they are probably ahead of 99.9999% of any other company. There are still tens of thousands of organizations that are extremely manual, and they are years, if not decades, behind where FANG is. They're behind Facebook, Amazon, they're behind Apple, they're behind Google. So, which means that even if Facebook might be shrinking some of the high-tech jobs and replacing some of the software developers, they're literally ahead of the curve. And over the next 5 to 10 years, there'll be other millions of organizations that are incredibly manual, and you will be helping them bring their operations into the 21st century and replace some of the woefully inadequate practices with modern applications of technology and AI. So to me, it is all very positive for the jobs that you guys are looking to acquire, or for the jobs that you're maybe looking for upskill for. So now let's take a look at what future is and maybe try to dissect some of the technologies that are driving some of the shifts today. I have to tell you, I have to update the slide today because over the weekend, you've all probably seen the DeepSeek and how they completely upended the business of Anthropic and OpenAI and Google and even Meta. And I took the screenshot that 1 hour, 2 hours ago. It was about maybe 3 or 4 hours ago. So we are a little out of sync, but still it is from today. So if I were to summarize it to a couple of sentences, we will see our faster, more nimble, distilled mixture of expert open source model who will be taking over the world. That is my prediction. And so the other things I think that were critical in DeepSeek's breakthrough and the technology that they now make in open source and available to anyone is that they are using pure reinforcement learning to match the most flagship model of OpenAI O1 at a 95% less cost. So this model is much smaller. The cost of inferencing is much lower. And on top of this model takes so much less computing cycles to train. Don't forget that this is the MOE, mixture of experts model, which means that even though you might have a very large neural network of 670 billion parameters, it will only activate the neurons related to your specific question. So for example, if you're asking it's a medical question, it will only activate those neurons. So computationally, those MOE models are very effective. These are not exactly new. The Mistral has been experimenting with MOE models. The Mixtral model is indeed an MOE model, but just the computational efficiency of what DeepSeek has done is amazing. The second thing they've done, which is absolutely amazing, is that they no longer require an SFT, supervised fine-tuned model. They only require a pure reinforcement learning. So why is it a big deal? That is the big deal, ladies and gentlemen, because SFT requires tens of thousands, if not of hundreds of thousands of hours from manual labelers. Humans have to label data, and they have to label billions of data points to be able to provide the model with those preferences. So the pure reinforcement learning model learns on its own from interaction by observing the behavior, and it does not need nearly any amount of labeled data to be able to capture human preferences. So huge advantage. The other thing is, in my belief, if you own any NVIDIA stock, go ahead and sell it now. So we used to have a monopoly. NVIDIA and the CUDA environment was pretty much the only one that powered all of the deep learning and AI applications. So what DeepSeek has demonstrated is that AMD is an equal contender, and they Instinct GPUs and their ROCm software, ROCm is kind of analog of NVIDIA CUDA, actually work equally well, and they can work equally well on both inferencing and the training of the model. So now at least we have two equals in a game, and it's interesting to see how that technology will play out to kind of the level, the playing field between AMD and NVIDIA. So now let's take a look at, in my opinion, three key pillars, what's driving today Gen AI. And we're not going to talk about just the normal advances in areas like time series forecasting. Let's just look at the three big pillars. In my view, those three big pillars are NLP, CV, and the multimodal. So NLP is particularly my passion. I spent 90%, 95% of my days in NLP. And of course, we've seen over the last decade a lot of the progression from invention of kind of deep learning models like CNNs and GRUs and LSTM for NLP applications, and then evolution of the transformer models, starting with the BERT, and then some of the newer models like a GPT and the T5, which is stands for text-to-text-to-text transformers. And then the whole idea of pre-trained models, or what I call them foundation model, where you don't need to teach the model from scratch what's the foundation of the language. You just need to give the model specific domain expertise. So the fine-tuning of pre-training model is saving 95, sometimes 99% of computational cycle. And we have engines today like a quantization and LoRa Inc. adaptation that actually gives you the ability to take a very large model, update just neurons instead of billions of neurons, and get a performance that almost equates the performance of the model, if you were to train it from scratch. So it saves tremendous amount of parameters, and those LoRa adapters are very effective computationally as well. And so if you look at the kind of two biggest breakthroughs that came with an NLP field in a couple of, say in the last decade, first would be, as we discussed, the pre-training, which means that you don't have to teach the model part of speech tagging and what the differences between the sentence segmentation. You just teach specific domain. And the second is the model self-attention, where you do not need to curate the features nearly as much. The model learns which features are important, and most of these models are multi-headed attentions, which means it pays attention to the part of speech or the part of the sentence or the neighboring words that's required without requiring you to manually create all of those features. So the second pillar is the CVE, computer vision. And we have a lot of flavors of different CNNs, convolutional neural nets, and the visual transformers today that work effectively for image classification. The GAN, so generative adversarial networks, are great in creating high-quality images. And then we have diffusion models like DALL-E, which enable you to create an image just based on a textual description. So I think there are two major pillars of the technology are the VITs, our visual transformers architectures, and the GAN that are allowing us to, what is the right way to say, that can allow us to do the step-by-step improvement in an image generation quality or image segmentation quality as you go through the steps, and it discriminates against the kind of fabricated image and the real image to really create a very realistic images themselves. I think the final one is the newest one. It's the multimodal approaches. There are two new techniques, the clip and blip. So the clip is the contrastive learning. So it aligns embeddings in a shared latent space for cross-modal tasks. The cross-modal would be a model that understands images and text at the same time. You don't need to align those models. You need to teach them what the image of the meaning of each is. The model literally learns from each modality simultaneously, and it's able to connect your, for example, visual modality to your text modality without any additional training. And then those models also becoming pre-trained, so you don't need to teach the model the text understanding. If you have images, you can get a pre-trained model that already can connect your kind of visual characteristic with your text characteristics. So the next big improvement, I think, is called an agentic system. So what is an agentic system? We have digital agents, just like the agents in a human life. So if you look at any big company, you might have your marketing specialist, your HR specialist, you might have your finance specialist, and all of those people work individually on certain tasks. And so agentic systems work in a very similar way. It is a digital system that independently interacts in the world, and the systems can plan their actions, they can act on their actions. And if you want certain operation, then your agent, you have like a master agent, we can fire up individual agents, and those agents will be doing that tasks, reporting back, and your master agent will be able to coordinate those tasks. So the need for agentic system, ladies and gentlemen, came from a very, very simple observation. The models are really bad, today's models, I should say, are really bad and doing multiple things at the same time. They're very bad at multitasking. If you give the model a very specific instructions, if you give a set of tasks, it actually is amazing. Most of them are amazing at following them with a consistent pattern. So you're going to get a consistent response to the same set of simple tasks. If you give model complex tasks for any type of ambiguity, it struggles. So those agentic systems allow us to overcome the complexity of this ambiguity by saying individual agent, like your manager agent or your master agent, that will trigger. So for analyst agent, it gives them task to analyze the data. For planner agent, it's going to give a task to orchestrate the task and distribute them between multiple players. For a checker engine will make sure that the tasks are interpreted and completed correctly. So all of those individual kind of small tasks where each agent has a very defined set of instructions, and those sets of instructions are very well planned and executed and checked, I think gives you a system that is extremely reliable, very repeatable, and has very limited amount of hallucination. And especially if you kind of try to build those applications, I think most of them are built in Python nowadays. And so you kind of wrap them all in your Pydantic objects. You're validating that the output of the object is exactly matching your predefined characteristics. And then your checker engine is verifying the content itself and doing some of the fact checking. Those systems tend to be very reliable and very repeatable. And so one of the first applications, which I think is very successful, of those agentic system is the cursor's YOLO mode. So if you ever used cursor for any type of automation in a software development, you know what if you kind of do the check mark and you say, yes, I want to enable the YOLO, it allows your agent to automatically execute terminal commands. So it doesn't need your user coordination. It doesn't need a confirmation. It can do the basic things. It can, create directory, create files, delete files, execute the command. You probably want to go a little bit conservative and at least disable certain type of commands, like in your deny list. And depending on how adventurous you are, so YOLO stands here for you only live once. So depending on how adventurous you are, you can either give it a very broad set of commands. You can say anything is allowed, or you can kind of start small and say you cannot delete file, for example, but you can run executions and you can create new directories and you can create new kind of YAML files. So I think this is kind of the first very successful, in my view, operation of the agentic systems. And then if you look at how NVIDIA would present their view on agentic AI in healthcare, it literally maps them down to the specific operations that a typical hospital or healthcare institution would have. So you'll have your research assistant, virtual lab, software security, video analytics. So each of them has a role and set of guidelines, and an agent is, or virtual agent, is responsible for executing them and reporting them back into your manager agent. And those are very well orchestrated and coordinated. And so if you take now your agentic system and you marry it with our multimodal ideas, what are you getting back? So think about why multimodal is so critical. If you happen, hopefully for all the good reasons, not going to happen to you anytime soon, but let's say you're visiting a healthcare professional, visiting a doctor. So when a doctor observes you, they do not just take your blood pressure, they do not just take your blood oxygen level or variety of the tests. They actually will administer or will prescribe a number of tests, and they will holistically interpret them. So how would they interpret tests? They will maybe measure your temperature, look at your eyes, look at your skin, look at your throat. They will look at your, depending on your condition, any type of medical images, CAT scans, MRIs, X-rays, and they will take all of this information. They would use their knowledge and expertise to combine it. So for example, if you are coughing, which I can hear, and you're sneezing, which I can hear, and your eyes are watery, and your throat is red, and you have an elevated temperature, maybe as a medical professional, I would condition you with a common cold. If you also had a test, let's say a flu test, influenza test, or a COVID test that happened to be positive, then they will diagnose you with COVID. So now none of it is happening in isolation, right? None of it is happening because I just took your temperature or just because I looked at your throat. It all happens because they looked at a variety of different conditions and symptoms. Now, if you were to train a separate model for each of them, one model to predict a symptom based on your, let's say, visual interaction. So I saw your throat is red. Another would be on a hearing. I listen to you or I hear how you're coughing. The third would be on your medical tests, which might be your, for example, MRI or your chest X-ray. So creating a separate model and aligning those models is extremely difficult and very time-consuming. So the multimodal AI, which is models that are trained simultaneously, taking into consideration all of those factors, are immensely powerful. And if you combine your multimodal with agentic, where agent, your manager agent, maybe prescribes a certain task or actions, and then each agent responding with specific conditions, specific recommendations, those are becoming even more popular. So I can give you another example of the multimodal and why I think it's a future. And this will actually include autonomous driving and not a specific healthcare application. So you might have seen a battle between Elon Musk and Tesla against the Waymo. And you probably, if you're paying attention to the self-driving cars, you've seen that everyone except for Tesla is using a combination of different radars. So for example, Waymo cars, they have cameras, they have a LiDAR, they have a radar. And the way the car's behavior is controlled is by taking into consideration multiple inputs. So the LiDAR is very precise at measuring the distances, versus computer vision is giving you more of like a visual cues and a context, like the humans are driving. So the way Elon is describing this technology is he would say, if I can drive with just my eyes open, why do I need all those necessary appendices like LiDARs in a car? But in reality, it's hard for the systems to be able to use the visual clues as effectively for the computer vision systems as for the human. And so now the reason Elon is so adamant about not using others is because they tried it at Tesla. Actually, the earlier model back up to like 2017 and 18 all had radars and cameras at the same time. But what they found is that building models for separately the radar and for computer vision and trying to align those models was an absolute nightmare. So they got rid of all of those radars. However, what Waymo have done is they built a single multimodal model that takes into consideration both computer vision from a cameras and the LiDARs and the radars simultaneously. So the multimodal model does not require humans or anyone to try to manually align the two signals. The model with the reinforcement learning learn how to combine those signals together without human intervention. So to me, as much as I love Elon Musk, I think that the future of the self-driving cars is multimodal and not just the computer vision devices like Tesla is promoting. So now let's see what are the technical challenges and where the technology will go in the near future and how we can possibly plan for those technologies. About 2 weeks ago, Elon was giving an interview and he said that all of the human data that was used for AI training was exhausted at the end of last year. So if you look at any of the modern AI models, whether you go to Anthropic, you go to OpenAI, you go to Google Gemini, you go to the Meta with the Llama family of the models, they have pretty much consumed everything that humans produced and was accessible to the model. All of the text, all of the images, all of the videos, etc. So no more human data has been left. So now, what can we possibly do? Well, do we allow the models to produce the synthetic data, essentially train themselves? Or is it going to lead us to a very dangerous precedent where the computers would teach computer how to code, and then one day they will just completely, in a very kind of utopian future, might take over the world, because how does it know what's the good coding practice versus the bad ones? If it teaches themselves, it's kind of dangerous, right? So it needs to be a lot of the guardrails around this technology before it can be unleashed to the real world. But then, in my view, the simple biggest technological problem is called the Moravec's paradox. When I grew up, I really loved science fiction, and I read all of the books that I could get around, anywhere from Ray Bradbury to Jules Verne. I loved them all. And so if I look at what the sci-fi writers of the past 20, 30 years ago would write, they would imagine that human in 2025 would all be playing on a beach, composing music, poetry, and text, and the machines would do all the hard work. Machines would cut the grass, machines would pave the roads, machines would build the building, and maybe wash the windows, right? What we learn today is completely opposite, which means that the tasks that require any type of physical cortex, right? The tasks that require the physical movement are the most difficult for the machines to do. The tasks that are composing music, writing poetry, or writing a software code are the ones that are actually the easiest one. So the paradox is the hard problems are easy and the easy problems are hard. And so how are we, based on what we know, what we believe are going to be those paradoxes? So the first one is the headcount. So looking back at our beginning of the presentation, we saw that 41% of the responders to the World Economic Forum said that they plan to reduce their labor because AI can have or can replace those manual tasks with the technology. So now the thing is, it frequently replaces the task that are very manual and usually very low paid with a task that require a very skilled talent to make AI happen, right? So if you replace a postal clerk with an AI engineer, the engineer probably makes a lot more money than a postal clerk. So the second is who is benefiting the most from AI technologies. So the companies who tend to embrace them would be your top 10, top 20 tech players, right? It's going to be your Google, your Meta, your Amazon, and Apple. And so the reality is the companies or individual people who are benefiting the most from technology are people who are very well trained in this technology. So for example, if you're a data scientist and you know how to use technology, you can write your code twice as effectively. It's going to be the biggest benefiter. If you are doing a very manual work and you've never seen how technology works, and you cannot really imagine how it's going to impact your work, it's just not going to help you. The third pillar is who will get help. So if you are very traditional legacy business that is afraid of cloud, afraid of technology, you're slow and inefficient, you will not get help because you're still your CIO. If CIO says everything has to be local, no data shared, no cloud, no technology, etc., that's it, right? They're going to be stuck in the same business and they will not see any benefits from technology. And the last one is, of course, the data requirements. If you want to get help from technology, you have to maintain your data. If you don't invest in the data and data practices and the knowledge management, then technology will be of a very limited help. And I think with that, we have about 15 minutes left, 14 minutes left. What I would like to do is to open it up for Q&A. I know there are a few of them in the chat. Let's see if I can start.
Yeah, do you want me to read them off to you, Nick?
Yeah. I mean, I can probably just go.
Okay.
But yeah, if you see any common threads, maybe Jose, you can help me bring them up to the top.
Yeah, I'll go ahead and read the first one. I think this was a little bit, you received this question a little bit further back in your talk, but in days gone by in the legal industry, tools like Autonomy and Recommend were the services of interest in document and knowledge management. Do you see AI as the next generation of these tools?
So I have to tell you, I don't know those tools personally, so I cannot respond to the specific tools. But if you look at investment in a legal tech, I think all of them are concentrated in space like legal research, being able to automate the contracts and the redlining, being able to find information quicker across multiple sources, both internal sources within your firm or corporate legal department, as well as some of the precedents, and connect them in a kind of smart and effective way. So I think legal industry, as much as it is very conservative, will probably see one of the biggest transformations, in my opinion, over the next few years. So maybe I'll just try to go. So AI is more friendly than Stack Overflow, completely agree. I also agree that impact of the AI will be distributed. It's going to be skewed, no doubt about that. So the question is, which industries or sectors are going to be most significantly affected, positively or negatively? So I think it's not about industry or sector. I think it's about the types of jobs, because we can say banking or finance is going to see significant impact, but the types of work. So your fintech engineers are going to grow and your banking clerk are going to shrink. So I think it all depends on the industry. that we're talking about. And if I didn't answer your question, please feel free to unmute yourself and speak up. I'm happy to have a chat. Trajectory of Gen AI models, fragmentation of services. Interesting question about one-size-fits-all model or specific models. I think the answer is it depends on how successful we're going to be with building our MOE or mixture of experts. So if we can have one model that can be very computationally effective and answering any question, then those models will tend to win, because building a very specific tuned model for a specific application is time-consuming and expensive. But I think in reality, we will see both, right? Because, so for example, if I use any type of a commercial model, like use like a Anthropic Claude 3.5, it's a very versatile model that can do most of the things, but it's computationally very expensive, right? Its inferencing is very expensive. If you operate in a specific area, let's say you're in the fintech industry, you only need the model that provides your financial response answers. You don't need to worry about your 600 billion parameters. So smaller models are more computationally effective, bigger models are more generic. And I think there will always be a trade-off depending on what you're trying to accomplish. So within organizations, I would say they will tend to deploy more narrow, custom fine-tuned models to minimize hallucination and reduce the inferencing costs. So that would be my guess. Will we be able to work part-time while our first year in the masters? Maybe Jose, that's your question. I think.
Yeah, I've already been speaking with the student.
All right. I think there are deadlines, intakes, all the good questions about applications, separate programs. The question about the healthcare. How will the doctors learn about AI? Good question. I don't know whether, so I think all of the doctors have to go through a process of upskilling. I think it's every 3 to 5 years, they have to go and get the training on kind of new drug interaction, new technology, new side effects. So I think, and hopefully what we will see is the doctors, the curriculum will change. And in addition to learning about the new side effects and kind of new compounds, new medical compounds, they will learn about the new technologies. I also think that we will see a lot more disruptive vendors. They would bring the technology. You know that telehealth medicine is growing, and to me that there will be disruptive vendors that they will just, instead of going and seeing a human, they will invite you to see a human augmented practice. And those practices will be a lot more cost effective, and naturally they will win a lot more market share. Okay, so Prino, your question about cloud cost with multimodal LLMs. So the multimodal models tend to be more expensive, and agentic obviously bringing the cost up. I think the good news about those agentic systems is agentic system does not have to go against a huge general purpose model like, let's say, OpenAI O3. So if your agent only works on a small task, and these tasks are very well curated, then you can, so essentially the way you build a agentic system is each agent goes against the model that is required to complete the task. And the task is very simple, very repetitive. You send this agent, or you whether it's an API or you have your custom model, you build your agentic system to use the most cost-effective model for each task. So you don't have to have the most complicated O3 model for each of the agents. Some of the agents are going to be perfectly fine with a small, tiny 2 billion parameter fine-tuned model, and that's how you use your agentic workflow. By every agent operating with a specific small model, and the model should not be overkill. The model should only be tuned to be able to, like the model should be only big enough to be able to sustain operation of a specific agent. How does the multimodal overcome the frame problem? I think it's a lot more technical question. Maybe we'll take it offline. interaction, workspace, human creativity, emotional intelligence. I don't know if I can answer this question. So unfortunately, modern models are not just your, they're not just paraphrasing, right? They're not just your contextual parrots. Those models are also very creative, and they create art or text or speech or music that is unique to how those models work. So I think the creativity of the models is probably close. I would say it becomes competitive with the creativity of the humans. And so the only way to continuously compete with those models is to never stop learning. So I don't know if the creativity is only the human trait. I think those modern models are extremely creative. All right, rapid advances of gen technology, personal information. Well, I think it's a good question about the personal information. I think depending on which model you use and how you use it, there are always ways to prevent certain data usage, right? There is a data governance policy you can set up. Do not use my data to train the model. Do not use my data to as a memory of my specific preferences. I think there is, unfortunately, as you use free models, your options are very limited. If you want to invest in a paid solution, then those paid solutions give you more data privacy. Yeah, I think if you use Google or Gmail, I think there's no privacy, right? It's just the same with the model. Privacy is gone. So the question about what's the difference between agentic systems versus SNPA, I don't know SNPA, so I can't really answer that question. But the reason agentic models are popular is because the agents interact with each other or with the humans using the conversational AI agent. So it's a conversational interface instead of programming interface. And I think that's been one of the biggest changes we've seen. So the question for Edwin, Jose, you might want to answer this one. We have courses on Gen AI, we have courses on advanced computer vision. So I think there is quite a few new courses, and the Gen AI course specifically focuses on multimodal. So I think there are quite a few in our program that are actually covering those topics. And now the last question about data privacy. Differential privacy. So I'll be honest, as a full as a open kimono, right? I can't consider myself a data privacy expert. So I'm not sure if I know what's going to happen if, like with the differential privacy, how GDPR is going to change it all. I think the reality is, so legally that's an unsettled area. What is the fair use of the data for model training? If the model, so for example, if I give you a textbook and you read a textbook on programming, you learn how to program from a textbook, and you wrote your new program, your new software. Is it yours? Or you need to attribute some royalty back to the book author? The general consensus in the law today that it's yours, because you learn from a book and then you wrote a software, and then your intellectual property is yours. I think there is a lot more discretion when it comes to AI system. If AI system learns from a book or from someone's code and it created something new, who needs to be like, what is the fair attribution, what are the copyright issues, etc. So I think the area of the law has not been fully developed, and over the next several years, we'll probably see how it unfolds.
And I think if I could, hopefully it's okay that I dive in and follow up on that question. What I'm more interested in your take on, I think, is it seems like these these techniques are going to encourage companies to feel more comfortable training models on sensitive data because there's a little bit more privacy guarantee. And I'm interested in your thoughts on, obviously that model can't necessarily be public now, but the potential performance enhancements to the company that's using, has the ability to fine tune on more sensitive data that might otherwise not have been allowed to touch a model previously.
I think it's a great question. So if I were to give an example, so for example, today's code models have been mostly trained on open source repositories. If you want to fine tune your coding model specifically to the needs of a specific company, say Boeing will fine tune it on Boeing internal repos, it will start producing the code that is more in line with Boeing coding standards and libraries and versions of the software. I think that is very much true. The question so it's better for Boeing, probably, but we also, if we go into more sensitive domain, like a banking or legal, where you have to maintain kind of the walls of separation, that becomes a lot more complex because it can learn general policies of the investment bank, but it also cannot cross the lines of are you on the sell side, on the buy side, and that information needs to be properly protected.
That's a really interesting perspective because it sounds like demonstrating that your privacy enhancing techniques still meet all of the privacy requirements is going to be one of the big challenges to actually leveraging that.
Possibly, yeah.
Cool.
All right, so I think we're at the top of the hour. Thank you so much for joining us today, for your thoughtful questions. If I didn't answer, well, maybe what I should do, I should just flash my my contact information. If by any chance I neglected to answer your question or it was too complex to be able to kind of do it in a blitz fashion for 20 seconds, what I'm going to give you guys is here's my email, here's my LinkedIn. Feel free to connect, feel free to shoot me an email. I'll do my best to answer if I can. If we miss something, then between Jose and I will try to get back to you with some of the responses. Thank you so much for joining.